Hey everyone. In this lesson we're just going to continue talking a little bit about what we've been doing for the last, I think maybe just the last lesson, which is on converting fractions to decimals and decimals to fractions. And what we're going to do in this one is I'm just going to work through a few practice problems and that'll kind of be it for this video. And then your next video will be a test review. I might do a quick example of everything we've covered if we have time for it, but I'll do the test review bit at the beginning so that if you feel that you don't really need any of the extra practice problems, then you can skip that stuff and just study the things that you need to. But yeah, so what we're going to do in this video is I'm going to do two practice problems going from fractions to decimals, and then two problems going from decimals to fractions. They're not going to be overly complicated, they're not going to be too different from the ones that you saw last time out, but then again your test questions won't be overly different from the ones that you saw in the last video and the ones that you'll be seeing in this one. So it's going to be a fairly straightforward process. We'll start with going from fractions to decimals, but what we're going to do is we're going to do one thing that we didn't really focus on last time, which is converting a mixed number or a mixed fraction into a decimal. So yesterday, or whenever you would have seen the previous lesson, we would have worked on turning something like this into a decimal. But today we're going to just change that. We're going to add a whole number in front so that we've got this mixed number here that we can then convert into a decimal. So, the important thing to note when you've got this mixed number, you could also take this one step further. We're not going to do that in this video, which is if I started you off with an improper fraction, you could convert it into a mixed number and then convert it to a decimal from there. So I could give you something like like 11 over 5 and say convert this to a decimal. Your first step would be to make it a mixed number. Get it into that form where you can see how many whole pieces you already have and then what you have left to work with beyond that. But if you guys want to see practice problems like that, I'd be more than happy to cover that. Maybe instead of doing one problem for everything in the test review, I can go over a problem or two like that. That's just sort of the upper end level of difficulty of what you might see. Like when we were doing arithmetic with fractions, the 4 basic operations, I can combine 2 or 3 of them into one question, and we can do a couple of these harder fraction to decimal questions. But that'll just be it for this unit. But let's tackle the problem that's in front of us right now. We want to turn this mixed number into a decimal. So what this is telling us, what this mixed number is telling us, is that we already have 8 complete pieces of whatever. We've got 8 wholes of whatever we're dealing with. You could go back to the pizza and pie analogy that we've used throughout this unit. You could say we've got 8 complete pizzas, and then we've got 7/16 of a pizza left over. And I want you to tell me, okay, how many pizzas do we have expressed as a decimal? Well, we already know we've got 8 pizzas, 8 complete pizzas, so I know it's going to be 8 and then a decimal point. It's all the stuff after the decimal point that's giving us some trouble. So what we'll do there is we will do some good old long division with just the fraction. We don't need to involve the 8 in that because we've already dealt with this. 8 is already over here, we've already dealt with it, so we only need to worry about this fraction. And so what we're going to do is we're going to take 7, maybe I'm going to slide that over a little bit towards the left. We're going to take 7 and divide that by 16. Remember, you've got to get the order right when you set up your division problem. Now, of course, this is going to be a division problem that involves a decimal answer. That's sort of the whole point. And one thing that you should note is that even though we've dealt with this 8 here, and in our final answer there's going to be an 8 in front of the decimal, when you're doing this division, because we're only working with the fraction, the answer that you get to this division problem is going to be 0 point something, because this fraction here represents a quantity smaller than 1. Just this fraction by itself would be 0 point something. When you tack on that 8 in front, that's where this 8 here comes from. So in our decimal answer over there, we're going to get 0 point something, and we'll just ignore the fact that we've got a 0 in front. We'll keep this 8 that we already have, and we'll just take all the digits after the decimal and throw them here after the decimal point. So let's go ahead and do that. 16 into 7 obviously isn't going to work, so we make this 7.0, and we're going to line up our decimal point up there as well. And so now we ask ourselves, how many times does 16 go into 70? And if we're not sure, we can count that out. I'm going to get rid of the title. Hopefully you've copied it down, or you've got something similar to it on your pages. So if we count by 16, so we get 16, then we get 32, then we get 48, then we get 64, then we get 80. Well, 80 is too big, so we'll have to stop at this 64 over here. And so that's going to give us 4 up top. So we get 0 0.4. We can put that 0 if you want. So we've got a 4 up there. 16 fours are 64. So we'll put that down here and subtract, and that'll leave us with 6. Now our next thing is to add on an extra 0 there and bring that down. So now we've got 60, and we can refer back to our counting by 16s up here. This is the last number that's smaller than 60, would be that 48 right there. So that means that we're going to do 16 times 3, so that will be a 3 up there, and we'll do minus 48 down here, right? 16 threes are 48, and that's going to leave us with 12. Right, now to deal with that 12, we're going to take an extra 0 at the end of our dividend, pull that down. Now we've got 120 down here, so we can count this out a little bit further. We got 80, then we got 96, then we got 112, and then we'll get, what, 128 by the looks of it. And so we can stop at this 112 right here, right? That's the last number that we'll get to fit inside 120 without going over. So if we just count that out, we get 16 times 1, times 2, times 3, times 4, times 5, times 6, times 7. So we're going to put a 7 up here. 16 times 7 is 112, so we put that down there and subtract. And that's going to leave us with 8 on the bottom. And now we put one more 0 over here, drag that down, and now we've got an 80 down there. And so now you can see we're almost done. We've got this 80 up here. 16 times 1, 2, 3, 4, 5 is 80, so we'll put a 5 up there. We subtract 80, and we're left with a 0 down there, which means that we're finally done the problem. So we've got this decimal answer of 0.4375. That's just for this 7/16 bit right here. So 7/16 as a decimal would be 0.4375. But we have this 8 in front, and we've already dealt with it by putting the 8 over there. So then we just take those digits from our decimal, that 0.4375, and we just throw that on the end of it, and we get 4375, and your final answer would be this 8.4375 would be your final answer. Sorry, I know that's sort of getting squished up there along with the division, but that would be your final answer for converting this mixed number into a decimal like that. Now I'm going to show you one more example where you could run into a little bit of trouble when you're trying to convert your mixed number to a decimal, because if I gave you something like 1/3 and like 1/3, and I ask you to convert that into a decimal, you're going to kind of get stuck, because the decimal representation of 1/3 is a number that never ends. It repeats, but it never ends. So you'd have a little bit of a problem there, right? So what we're going to do is, on the test, I will hopefully try and remember this. I'll remind you on the test paper itself that you don't have to go past the second or third decimal place. So if I asked you to take that 0.4375, and if I said only go as far as 2 decimal places, then you can stop at this 43, and then you're just going to look to see, is this closer to 0.4375 0.4300, or is this closer to 0.4400? That way you can sort of round it off. You can chop off everything after the second decimal place and give me whichever answer is closer. For one like that, don't really worry about it too much. I'll try and work something out so that either you don't have to worry about that rounding at all, or maybe just that plain and simple you don't get any complicated decimals that you don't have to worry about rounding. So keep this in the back of your mind, but don't focus too much on this rounding business, because we didn't really talk about rounding very much. I'm going to do my best not to give you ugly fractions that take a lot of work to express as a decimal. But we're going to do one now just for practice. So we're going to take 13 and 8/11, or 8/11, and we're going to convert that into a decimal. Now, we already have this 13 over here, so I'm going to take that 13, I'm going to throw it right there before I put a decimal point. So now we've dealt with this 13, right? Now we need to deal with this 8/11 business. And to do that, we're going to long divide. So let's do that. I'm going to write it over here. So it's 8 divided by 11. And to start, obviously 11 doesn't go into 8, so we're going to make this 8.0 and treat it like it's 80. And we're going to line up our decimal point up there. Now 11 into 80. 11 goes into 80 7 times, so we'll put a 7 up there. We're going to have a 0 here, that's optional though. So we've got a 7 up there. 11 times 7 is 77, so we put that here, and we subtract. That'll leave us with a 3. Then I'm going to tack on an extra 0 here and pull that down. So now instead of a 3, we've got a 30. Now with this 30, how many times does 11 go into 30? It's going to go into 30 twice. 11 times 2 is 22. You can work that out if you're doubting me. But 11 times 2 is 22, 11 times 3 is 33, which is too high, so we have to use the 2, and that's going to leave us with 8 down there. Now you might notice that our original problem was dealing with an 8. So of course, we add on that extra 0, sure, we bring it down. Now we've got an 80. But if you remember, back at our first step, we were still just dealing with 8, which we turned into 80, and we got an answer of a 7 up top. If you're not seeing it yet, you should hopefully see it after this next step. 11 goes into 80 7 times, so let's put a 7 up there. 11 times 7 is 77, which should look familiar since we did it up there, and that's going to leave us with a 3. We already had a 3 left over as our answer earlier when all we had was this. When we didn't have anything extra beyond this point, we only had a 3. We added a 0, we pulled it down, we got a 30, and we did the whole next step. We got that 2 up there, did the subtraction with that 22, we were left with that 8, and that brought us down to here where we've got this 3. If you want, you could keep going, you could put another 0, you could pull that down. We've got a 30. Looks familiar. We already did this stuff with a 30 right up there, right? But you could ask yourself again, how many times does 11 go into 30? It's going to go into 30 twice. We can subtract 22, and I'm running out of space down there, but you would be left with an 8 down there. You might notice at this point that we're sort of repeating steps, right? We started with an 8, we did some math, we got back to an 8. We did some math, we got back to an 8. Or we started with that 8, turned it into an 80, did some subtraction, got left with a 3. Did some more math, got left with a 3 again, before pulling down that 0. And so you can see that this pattern is starting to repeat itself. The numbers that we're left with after we do the subtraction is starting to repeat. First we had a 3 left over, then we had an 8, then we had a 3, then we had an 8. Next one, chances are going to be a 3. And so what that's telling us is that these numbers that we have up here are going to keep repeating, because we have the same situation playing out over and over and over again. First we had a 7 up there, we did the math, we got left with this 3. Then we put a 2 up there, we did the math, we were left with an 8. Put a 7, did the math, we were left with a 3. Put a 2, did the math, we were left with an 8. It was just going to keep cycling back between us putting a 7 and then a 2, 7 and then a 2, 7 and then a 2, until the end of time. So, what you can do is, if you want, on the test, or just if whenever you need this stuff in future, you can put 13.727272 if you wish. You can just go 4 or 6 or whatever decimal places, whatever makes you feel comfortable. Or I might tell you chop it off after 2 decimal places, so you can stop at 13.72. Or what you can do is, if you remember, I believe I mentioned this notation, is that if you have decimals that repeat forever, you write it down once, and then the stuff that repeats, so in this case we've got 7-2 repeating, we'll put a bar over that 7-2 the first time it occurs, and we just get rid of all the 72s after that. We don't have to put a ... or anything like that. No ellipses, no extra decimals, no never-ending decimals, just that bar on top, and that tells you that it's 13.72727272 forever. Alright, so that's one thing to sort of be watchful of, is if I give you a fraction like 1/3, you could sit there and write out your decimal answer of 0.33333333, or you could put 0.3 and stick a bar over it and be done with it. Alright, I'm going to try and steer clear of those types of problems when it's time for the test. But I erased the long division, but if you look at your quotient, our quotient was 0.727272. So that's 0, obviously, we're taking that 0 and kind of throwing it out, because we know we have, in this particular question, this whole number, this 13 to deal with, which is why we have this 13 over here, right? Otherwise, we wouldn't have to worry about it so much. So this 0, we end up throwing it out because we've already dealt with the whole number, and then we're doing that long division just so that we have this decimal stuff to throw in after the decimal point. Alright, hopefully that's making sense. So that's the last example that we'll do for going from fractions to decimals. Now let's switch gears. We'll go from decimals to fractions. Oops, dropped my pencil sharpener. So let's go from decimals to fractions next. So let's start with, we'll just do 2 examples of this and then I'll let you guys go. So the first one we'll do is, let's take 10.4274, let's say, and we want to convert that into a fraction. Alright, so we've got a decimal number, 10.4274, and we want to convert that into a fraction. So we know we've got 10 wholes, right? We've got 10 complete, finished, polished products. So we know that as our fraction, we're going to have a mixed number where the whole number is 10. We need to figure out what this fractional part will be. So to do that, we'll ignore the 10, because we've already dealt with it over here. We just look at the digits after the decimal point. All the digits after the decimal point, we just take them, throw them into our numerator. So we've got 4274 as our numerator. And then for our denominator, we're going to put down a 1. And then we're going to count how many digits we have after the decimal point. So we've got 1, 2, 3, 4 digits after the decimal point. So I'm going to throw 4 zeros after the 1 in my denominator. The other way you can think about it is that this is in the 10ths place, the 2 there is in the 100ths place, that 7 is in the 1000ths place, and this 4 is in the 10,000ths place. So if you want, you can think of it that way. So we've got tenths, hundredths, thousandths, 10,000ths, and so because the last digit that we're considering is in the 10,000th place, we put 10,000 as our denominator. So you can think of it in whatever way works best for you. For me, I just, counting is easier than figuring out the place values, especially if you've got like 9 decimals. I don't want to sit there and go, okay, millionths, 10 millionths, 100 millionths, and then try and work it out that way. I'm just going to count how many digits are after the decimal point and throw them all in there. So now we're almost done, but all we have to do now is we just need to reduce. So we know this 10 isn't going to change, but that fraction over there, both of those numbers are divisible by 2. They're both even numbers. So let's divide both of them by 2. The bottom looks easier, so we'll turn 10,000 into 5,000 if we divide it by 2. And our numerator is 4,274. So if we divide that by 2, 42 would become 21, 74 would become 37, And if we're not sure, there's no problem with, let's get rid of this stuff here. There's no problem with just going ahead and doing the long division as well. So we've got 4274 divided by 2. 2 goes into 4 twice, minus 4, nothing. 2 once, minus 2, nothing. 7, 3 times, minus 6 leaves us with a 1, bring the 4 down, and the 7. 2137. Yep. So that should do. And beyond that point, I don't think we can reduce this anymore. I think we're going to kind of have to stop there because, well, they're not both even numbers. Even if that top number is divisible by 3, which it doesn't look like it is, this bottom one definitely isn't, because if you sum up all the digits, it's not going to give you a value that's divisible by 3. So we can't divide both of them by 2 or 4 or 6 or any other even number, because the top one is odd. It's not divisible by 3. Yeah, we'll probably have to stop here. There might be a way to reduce it more. I definitely don't see it. It looks like this is the most you can do. Either way, on the test, I'm going to try to steer clear of giving you decimals that'll result in fractions like that. I might give you a decimal that has 4 or 5 digits in it, but it'll reduce to something like, 1/16th or 1/32nd, or I'll make it a nicer fraction when you do that conversion than something like this. So yeah, so that's basically it for this example then. So we'll do one more, and this video might, I guess, turn out a little bit shorter than some of the recent ones, but that gives you guys a little bit of a break, and you can use any free time that you do get from this to catch up on some studying, either for this course or for your other courses, or just, relax and enjoy yourselves for a little bit, because most of these lessons have been quite long recently. Let's do one more. So here we're going to have, let's say, 202. What did I work out earlier? 202.044. That's the one we want to convert. So we want to convert 202.044 into a fraction. Now we know we've got 202 complete units, so it's going to be another mixed number with a whole number of 202. Now, for our fraction, the numerator is just going to be whatever came after the decimal point, which in this case is that 044 right there, is just going to be our numerator, which, if you looked at the number 044, you would not call it 044, you just call it 44, so we put the 44 up top as our numerator. Putting the 0 in front doesn't change anything, because we don't have a decimal point. We don't have a decimal point up there. And for our denominator, here we have to be a little bit careful. We stick down a 1, but now we have to not forget this 0. So we've got 044 after the decimal point. That's 1, 2, 3 digits after the decimal point, so I have to put 3 zeros after my 1 in my denominator over there. Or the other way you can think about it is this 0 is in the 10th place, that 4 is in the 100th place, and this last 4 is in the 1000th place. So because it's in the 1000th place, we put 1,000 as our denominator. So that's the other way you can think about it. Now once again, this is basically all of the grunt work of the problem is done. Now it's just a matter of reducing. So if we want to reduce this, it's going to go 202 and 44 over 1,000. The 202 can stay the same, but both of those are divisible by 2. So let's divide both of them by 2. There are bigger things that you can divide them by, and it's fine if you spot them, it's fine if you don't. But if you just notice, okay, they're both even numbers, let's divide it by 2. Worst case, you just end up reducing it twice or 3 times. It's not a big deal. So let's divide them by 2. And so that numerator is going to become a 22, and our denominator is going to become 500 instead of 1,000. So we've divided both that numerator 44 and a denominator of 1,000 by 2. So 44 divided by 2 gives us 22, and 1,000 divided by 2 gives us 500. Now, those are both still even numbers, so that means that we can reduce them again. And so that's going to mean that we can divide both of those by 2 one more time. So let's do that. 22 divided by 2, that's going to give us 11 on top. And on the bottom, 500 divided by 2, that's going to give us 250. Now 11 is a prime number, and it doesn't look like 250 is a number that's divisible by 11, so chances are we can't reduce any more than this. So your final answer would be 202 and 11 over 250. And that would be how you represent 202.044 as a fraction. Alright, so as you might be seeing, if I'd just gotten rid of this 202 and I made the problem 0.44, then you would have just gotten an answer of that fraction. If you have anything before the decimal point, any whole number here, then you just sort of throw it down there. It goes from being a proper fraction to a mixed number, but other than that, there's no real difference. Alright, hopefully this is all making sense. As I said at the beginning, I can cover a little bit more of this, perhaps a slightly more complicated example or two in the next video, but the next video will be a test review, and we'll get the test review stuff out of the way first so that you can stop it right there and study if you wish. But after that, I can go through an example or two of some more complicated stuff based on the topics that we've covered in this unit, and then that would be it for our fractions and decimals units. Your test, by the time you guys are watching this, your test should be around the corner, but so is our next unit, which hopefully we'll have a fun surprise or two, but I will tell you more about that in the coming days. Yeah, if you have any questions, get in touch with me, but otherwise I will see you in the next video. Have a good one.